Hello guys, this is Prashant from MyLearnCube. So in this lecture we will see some questions based on binary codes and number system. Okay. Now the first question is that has been asked in some previous gate. This circuit is given to you and you have been asked that what this circuit actually represents. What kind of circuit it represents? Code converter. That means it is given that it is a code converter. Now you have to tell, you have to answer which type of converter is this. So the very simple way is y4. Y4 is nothing but this such kind of symbol, such kind of circuit. This means 0 volt. 0 means ground. That means one of the input to this gate, suppose this is G1, G2, G3, G4, gate G1, G2, G3, G4. So one of the input of XOR gate G1 is ground, and ground means its input voltage is 0. So for this G1 we can directly write Y4 is equal to X4. Very simple. Now for Y3, if we see the output Y3 will be given as, here X4 is coming and from above this is X3. That means Y4 is nothing but your X4 XOR X3. Clear? Now see Y2. For Y2 we have three inputs. One is coming this way. This is nothing but your X4. Second one is coming from this way. This one is your second one, which is nothing but your X3. And X2 is coming from external input. So X2 XOR X3 XOR X4. So this is your Y2. And on the similar note, if you will see, Y1 is given as X1 XOR X2 XOR X3 XOR X4. So this is your four equations. And if you have keenly observed, if you have seen my previous lecture, these are nothing but keenly observing it. Suppose this is your X4, this is your X3, this is your X2, and this is your X1. So we are getting Y4 directly. Now we are getting Y3 as the XOR of X4 and X3. That means XOR of these two, which is nothing but X4 is nothing but your Y4. So the XOR of this thing you are getting. Okay. Now the next X2 in Y2, for Y2 you are getting X2 XOR X3 XOR X4, which is nothing but your Y3, which is nothing but your Y3. So this way, that means this Y2 is nothing but X2 XOR Y3. This is the way. And again, if you will see Y1, so Y1 is nothing but your X1 XOR, whole this term is nothing but your Y2. That means Y1 is XOR of Y2 and X1, which gives your Y1. And from here, from this simple equation, you can tell that this is nothing but what? Your gray to binary converter. Your gray to binary converter. Let me change the ink option. It is creating some problem. Okay. So it is nothing but your gray to binary converter. So this question already has been asked in previous year gate question. Okay. So the next question is very crucial. Means from this question you will learn a trick. What is the equivalent 2's complement representation of 2's complement number 1011? That means 2's complement number. That means it is some negative number. 1011. So you have to tell which of these four options is equivalent to this number in 2's complement representation. So if you will, what is the way to know the magnitude of this 2's complement number? Take its 2's complement and then put minus sign in front of the result. So when you will take the complement of this number, you will get 1 0 1 0 and put minus sign in front of this. It is nothing but minus 5. There is also one trickier way to find the magnitude directly. This is 1 0 1 1, and from the perspective of 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, which is nothing but 8 4 2 1. And I have already told you that for negative number the MSB represents sign bit. This represents sign bit. So the direct way to compute the result is, for this put -8. Whichever your sign bit, put -8 plus, this is nothing but 0, plus it is representing 2, it is representing 1. This is -8 plus 3, which is -5. So that means this number, the given number is representing -5. Now the conventional way or to solve this question, take these number one by one, find their magnitude, and the number which has magnitude equivalent to -5, that will be the result. So from the result, from the options itself, you can cut out these two options. Why? Because their sign bit is 0 and 0 sign bit represent the positive number. So these two options cannot be the answer. Now there are two contestants for this, C and D. We will see one by one. Okay. For C itself, we can see here only. For C option, 1 0 1 0 1 1, and this way, this using this trick we will get 1 2 4 8 16 32. That means -32 plus 8 plus 2 plus 1. That means -32 plus 11, which will give you minus, I think, 21. So which is not equivalent. So this is not answer. This is the correct answer. Though we will check it again by our own. This is 1 1 1 0 1 1, which is 1 2 4 8 16 32. Let's check it. -32 plus 16 plus 8 plus 2 plus 1, which is nothing but -2 plus 16 8 24 and 3 27, which is equivalent to -5. Hence option D is correct. So this is the, guys, this is the conventional or traditional approach to solve this question. Now we also have one concept called sign bit extension that will help to solve such kind of question in 1 second. Sign bit extension. So we have seen 1011 in 2's complementary form. It is giving us -5 in base 10. Now if I represent this 4 bits, the same number in 5 bits, so I will do 1 1 0 1 1. Now try to analyze its result. It is 1 2 4 8 16. That means -16 plus 8 plus 2 plus 1, which is nothing equal to 5. Same result. If I represent this in 6 bits, let's represent it 6 bits. Just but you have to do, you have to repeat for each additional bit, you have to put your sign bit value. Whatever the sign bit value, you just put this way. That means if you are going from 4 bit to 5 bits, to 5 bit representation, whatever is in your sign bit, suppose here is your banana. I am taking just an example. In fact, the real answer is 1 or 0. So if there is here is 1, then put it in this extra, the additional bit 1. If 0, then 0. Again, if you are representing in 6 bits, suppose 6 bits, 1 2 3 4, then put these 4 bit as it is in these 4 bits, and for the additional 2 bits, whatever be the value in your sign bit, put here. Whatever be the sign value in the sign bit, put here. The resultant will be the same. Check it here. Now representing it in 6 bits will give you 1 1 1 0 1 1. Check it again. This is your nothing but 1 2 4 8 16 32 -32 plus 16 plus 8 plus 2 plus 1, which is nothing but -32 plus 27, which will give you -5. Again the same thing. So this is a concept called sign bit extension. Using such, now at random I am giving you some question, 1 0 0 1, suppose 1 0 1 0, and there are 4 options. Now the option, this option is correct one. If you will try to compute this question, means if you will try to compute the magnitude way, the conventional approach, then it will take at least 2 to 3 minutes or maybe 5 minutes in some case. But in this case, you can see, okay, this is the number and all these are the sign bit. So this is the sign bit extension. That means these two numbers are equivalent. Now see the previous question again. So they are asking 1011, which is equivalent. So directly you can see 1011, but 0 not possible. Positive number not possible. Now see here, 1011 is there, but here the sign bits are different. Here the sign bit is 1, but it is 0, so it is not possible, and you can directly put the answer this one. That means 1011 is there and it is repeating the sign bit. So using the sign bit extension, this question is very easy to solve. Now one of the question has been asked in Morris Meno book. So it is a 2's complement number x3, x2, x1, x0 is stored in a 6-bit register. The number itself is of 4-bit, but we are going to represent it in a 6-bit. So which of the following indicates the value of register? I think now it is very clear to you, but we will repeat it again. So is this clear? No. Because if x3 is 1, then it is right, but we don't know the value of x3, so it is wrong. On the similar note, it is wrong. Now see this answer again. What they have done, for each of the additional sign bit, they have put the value whatever be the value in the sign bit in the original code, they put the same thing here. So this is the correct answer. So if you know the concept of sign bit extension, this question hardly take 5 to 10 seconds. The time you need to read the option, only that time you will take, otherwise it will not take much time. Good. Now next question. A register contains a 2's complement number 10100. Find the value of the register if it is divided by 2. Okay. Now again, this is the number. They are saying divided by 2 and give the result. So one of the traditional approaches, you will immediately compute its magnitude. The 1, 2, 4, 8, 16. The magnitude is minus 16 plus 4, which will give you minus 12. That means this number is representing minus 12. So one of the way is minus 12 by 2 is minus 6. You will give the result. Now you have to represent minus 6 in 2's complement representation. How will you represent? First you will represent this way. This is your plus 6. This is actually your plus 6. Now this plus 6 you will represent in terms of 2's complement representation, and its 2's complement representation would be this way. So this is your minus 6. So this is equivalent to this one. Representing it in suppose 6 bits, just you have to repeat the sign bit 1 1 1 0 1 0. So this is your final answer in any number of bits. Suppose you want to represent it in 5 bits 1 1 0 1 0. Done. But there is another way. Suppose this number would be very large. Suppose this number is something like this one. So how will you do? So up till now, all you can do, you will just compute its magnitude and then you will divide it by 2. So if the question is this one, then it will easily take your 5 minutes at least. So there is a way, there is a trick for this also. So the number was given to you, actually was it is 10100. It was given to you, and you know that it is a negative number. So there are two operators in our computer science or digital electronics. One is right shift and one is left shift, and the right shift implies divided and the left shift implies multiply. So these are the two concepts we are going to use. So these two operators are right shift and left shift. So this number is given to us, and whenever you do right shift, it is divided by 2. Whenever you do left shift, it is multiplied by 2. So they have asked that you have to give the answer of this code when it is divided by 2. Just simply you do right shift of a bit. So whenever you do the right shift of this number, we have 1 2 3 4 5 bits. So this will go out, this will come here, this will come here, this will come here, and this will come here. Again, the main thing here is you have to, this additional bit is there, and all you know for additional bit, what you know, whatever be the sign bit answer, whatever be the answer of your sign bit will be put in your additional bit. So this is your answer. If you will compute the answer, see, this is 1 2 4 8 16 minus 16 plus 8 plus 2, which is nothing but minus 6. Hence the answer is correct.